Hi guys, my name's Gia. Today I'm going to be doing another virtual experiment with you guys, and this one is about a virtual gravity pitch. So basically you're going to imagine that you're standing, you have this gigantic pitcher standing on Earth, and he's ready to throw a huge baseball. And we're going to hypothesize what we think will happen as the ball is thrown harder and harder with more speed, greater velocity, greater weight. And we're going to observe the path of the ball when it's thrown at these different velocities and at these different weights. We can also throw the ball on different planets to see how each planet's gravity is going to affect the ball. So I'm going to start by sharing my screen and launch this experiment. So say we want to change the velocity down here to 1 kilometer per second. We can hit play. The ball does not go very far. It's not enough velocity. So we could try something a little bit more. Let's maybe try 4. Okay, a little bit farther. Definitely made it farther, but it's not making it quite as far as we'd want it to be. You want to see as far as we can get it. Add a little bit more velocity. Let's go up towards like 8. Okay, that's definitely getting some arch, and it's literally landing off of the planet. So it's still traveling. The distance being traveled is still going on. Oh, here it comes. It came all the way back into orbit. Oh, and it hits him. So you can see 8.4 kilometers per second actually was enough velocity to come all the way around the Earth. So what happens if we go all the way up to 12, which is the most that we can do? So you want to remember the planet's mass is 1, the radius is 1, the pitcher height, he's about 1,500 kilometers tall. Obviously very unrealistic. Nobody is this tall. He's like a quarter of the whole planet height, but let's see what this velocity will do. You can already see that the arch that is being made is much larger than the previous one. He's coming this way, whereas the one previously was more like this. So let's kind of predict. If it's going this way, where would it go? Okay, this is the cool part. 12 kilometers per second actually has an infinite distance traveled. It is so fast and has so much velocity that it will continue through space forever. There's no stopping point unless it, of course, hits another planet or maybe hits a meteor in the sky or something, but it's never coming full round. So let's go back and meet halfway at like 10, because we did 8 and 12. And now let's see where like 10 takes us. See, it's definitely not as big of an arch. And it still says that the distance traveled is infinite. So let's try Mars. This planet is obviously a lot smaller than Earth. So if we do about 4 kilometers per second, which did not make it very far on Earth, it actually is making it pretty far on Mars. It's going around the planet. And then it's infinite. So because the planet is smaller, it takes less velocity to reach that point. Let's try Venus, which is larger than Mars, but still smaller than Earth. And not enough velocity to make it all the way around. And let's try a custom planet. What if the radius was bigger than Earth and the mass is larger than Earth? Because you know that gravity is based on the mass and the radius and that of different planets. So if we do 6.8 kilometers per second and hit play, let's see, not making it very far, not enough. What about 12? oops, that wasn't it. Like 11.5. And yeah, what we would expect it to be. It's going around, but it's not hitting infinite. So that's making me think it's probably going to come all the way back around. Let's see. Yep, based on gravity, it comes back. Oh. Which is the crazy part. Just by increasing the radius and the mass a little bit, bigger than Earth, the velocity doesn't do as much. So there's all these other tools. We can screenshot it if you wanted to. So I hope you guys learned a little bit more about gravity and how a planet's mass and radius will affect the distance traveled when throwing a baseball or something like that. Obviously, this is a very dramatized experiment because nobody could throw a baseball all the way around Earth or out of our atmosphere, but it shows a pretty cool experiment. So thank you guys for watching.